This video covers the solutions in-class activity for Part B. For question 1, they are asking what volume of a 3 molar methanol solution is needed to provide 0.32 moles of methanol. So here we're going to use the definition of molarity. So molarity, remember that's big capital M, and that's moles of the solute. So what's being dissolved in the liters of solution. So remember the solution contains the solute and the solvent. So I'm just going to set up a proportionality. So if we have 3 molar, so I just wrote it as 3 moles for every 1 liter of solution. So for every 3.10 moles of 1 liter solution, we can set up a proportionality. So 0.32 moles is to X, because that ratio is going to be the same. So I can cross multiply and divide to find my volume of the solution. So when I do this, I'm going to move my X to the other side, divide my 0.32 divided by the 3. And so this is how I get the 0.107 liters, but I need to convert that to milliliters for the answer because they want the volume and their answers choices are in milliliters. So I move the decimal over 3 places. So that's 107 mils. Okay, then in question 2, we're really looking into the difference between molarity and molality. So this is a lowercase m, so you have to be very careful and pay close attention. So this is a little m, a lowercase m. Little m is molality, big M is molarity. And if we look at those definitions and the differences between the two, we should be seeing 2 major differences because they're both moles of the solute. That's what we're dividing by. The molality is kilograms, whereas molarity is liter. And in molality, that's kilograms of the solvent. So just what it's being dissolved in, whereas molarity is 1 liter of the solute plus the solvent. So that's the liters of solution. So there's a difference between that. So we're looking at a 0.5 molal solution. So little m's, we're looking at molality. So if the solution is 0.5 molal, so that's 0.5 moles for every X grams of kilograms. So if we solve for X, that's 1 kilogram of the solvent. And then so when we make that solution, all we have to do is measure out the kilogram of solvent and put the 0.5 moles of that solute into that mass of the solution. Whereas with molarity, the big difference with molarity, you dilute up to the mark. Molality, you just weigh them together and combine them. But the molarity, you have to, especially if you're working with like a known, specifically known concentration, you're typically using a volumetric flask. You add a little bit of your solvent to the volumetric flask along with your solid, and you stir and you mix it up and you get it dissolved, and then you dilute the volume up to the line. So you dilute it up to add enough water so that you make the total volume, the volume of the flask. So that's how we get the liter of solution. But with molality, lowercase m, molal, we're just adding a kilogram of the solvent. So be careful that you're making the distinction between little m, molality, and big M, molarity. Yeah, so we're going to add 1 kilogram of the solvent. Now in question 3, they want to know the mole fraction of I2 in a solution made by dissolving 11 grams of iodine in 245 grams of hexane. So mole fraction is the moles of 1 part over the total moles of everything in the mixture. So since we have the mass of the I2 and the mass of the hexane, we're going to need to convert those masses into moles so we can use the mole fraction. So I started off with my mass of I2. I divided it by the molar mass of I2 to the grams per mole, so the grams cancel out. So this is how I'm getting my moles of I2. I'm going to do something similar for the hexane. I've got my 245 grams of the hexane. I'm converting it to moles using the molar mass. So 86 grams per mole. And this is where I'm getting the 2.84 moles of hexane. So now that I've got the moles of the hexane, moles of I2, I can start plugging into my mole fraction equation. So the moles of the part, the I2, over the moles total. So if I plug this into my calculator, this is where I'm getting a mole fraction of 0.133. So B is the correct answer for number 3. Now in question 4, how much water must be added to 38 grams of calcium chloride to produce a solution that is 35% by weight calcium chloride? So percentage part over the whole. So for expressing the percentage of calcium chloride, so for every 100 grams of solution, it's 35. So this is our percent, 35 out of 100. So I'm just setting up a proportionality. So for every 35 is to 100 as 38 is to X. So cross multiply and divide to find your X. So the X grams of solution is 108.57 grams. So that's the grams of the solution. But they want to know how much water we need to add. So the mass of the solution is going to be the mass of the solute plus the mass of the solvent. So we know the mass of the solution is 108.57. And we know that the mass of the calcium chloride is 38. So if we subtract the 38 from the 108, this is where we're going to get the mass of the water here. So that's what we're looking for. So that's where we're getting the 70.6 grams of the water as the mass of the solvent that we need to add. You've got to pay close attention and be careful with these multiple choice, because see how if you would have stopped with just the mass of the solution, if we rounded this to 3 sig figs at 109, notice that they have that here, but that's not what they want. They don't want the mass of the solution. They want to know how much water, the solvent. So pay close attention to those types of details. Then in question 5, they're telling us that this solution of lithium chloride has a mole fraction of 0.07 lithium chloride, and they want to know the molality. So we're going to convert from mole fraction to molality. So if mole fraction is moles of one part over the sum of everything. So to get the mole fraction to be 0.07, and we know that we have 0.07 here, we know that the bottom number here has to add up to 1. So the sum of the moles of the lithium chloride and the moles of the water have to add up to 1, so that when we divide the 0.07 by 1, we still get the 0.07 for the mole fraction. So by subtracting the mass of, the moles of the lithium chloride from 1, this is where I'm getting the moles of the water. So there's 0.93 moles of water, 0.07 moles of lithium chloride, both of those add up to 1. So if I want the molality, remember molality is moles of the solute, so the 0.07 divided by the kilograms of the solvent. My solvent is water, but I've got 0.93 moles. So I've got to take that moles of water and convert it to grams and then to kilograms. So my 0.93 moles of water using the molar mass, 18 grams, that gives me grams of water. And for every 1,000 grams of water is 1 kilogram. So this is where I'm getting the kilograms of water. So now I can plug this back into this equation to get my molality. So this is where I'm getting 4.18 as the molality of that solution that has a mole fraction of 0.07 for the lithium chloride. So that's how I'm getting D for number 5. Now in number 6, how many grams of KBr are required to make 650 mils of a 0.115 molar solution of KBr? So we have the molarity and we've got the volume. So anytime you have molarity and you've got a volume, because molarity is moles over a liter of solution, so you've got moles and volume. So if I've got molarity and volume, I can get moles. So I'm going to start out this problem by taking my molarity, but I'm going to just go ahead and write it as 0.115 Instead of molar, I'm going to write moles per liter. So this is the way I can watch my units cancel out. So I've got the 0.115 moles of KBr per 1 liter. So I'm going to combine the molarity and the volume. My volume's in mils. This is in liters. So I'm going to do a unit conversion here. So for every 1 liter is 1,000 mils. My liters will cancel out. And then I'm going to multiply by my volume so that my mils cancels out. So that leaves me with units of moles. And then I'm going to convert my moles to grams using the molar mass because I want grams. So the molar mass of KBr is 119 grams per mole. So just to show you, watch those units cancel out. The liters cancels out. The mils cancel out. The moles of KBr cancels out, and that leaves me in grams of KBr. So if my units work, that typically means my numerical values are going to work. So I highly encourage you to keep adding those units there so you can watch those units at the end. So I'm getting 8.9 grams of KBr, and so this is how I'm getting D as my answer for number 6. Okay, number 7, last one. So we have a solution and we're going to dissolve 18.2 grams of benzene into the 282 grams of carbon tet. So this is the smaller amount, and they're also telling you it's dissolving in the carbon tet. So the benzene is our solute, and the 282 grams of carbon tet, that's our solvent. And remember, let's see, they're wanting it in molal. Molal is moles of solute per kilogram of solvent, so you have to be very careful. And remember, we said that the benzene is a solute, the carbon tet is the solvent to make the solution. So we need the benzene in units of moles, and we need the carbon tet in units of kilograms so that we can get that molal. So I'm starting off with my mass of the benzene because I want to convert this mass into moles, because I wanted to divide my moles of the benzene divided by the mass of the solvent, the carbon tet. Okay, so I'm going to set up my train tracks. And the molar mass of benzene is 78.1 grams per mole. So I just put this so that the grams will cancel out. Now I'm going to divide it by, since I'm in moles of my benzene, so this is my solute, I'm going to divide it by the mass of the solvent, so the 282, but that's in grams, and molal is per kilogram of solvent. So I'm going to do a unit conversion. So for every 1,000 grams of carbon tet, is 1 kilogram of carbon tet, so those grams cancel out. I'm going to show you how my units cancel out. So my grams of benzene cancels out. My grams of carbon tet cancels out. Now I'm left in units of moles of benzene per kilogram of carbon tet. So that's the same as molal. When I put this in my calculator, this is where I'm getting the 0.826. 0.826 moles per kilogram, and that is little m molal. So this is how I'm getting D as the correct answer for number 7. And notice here, they like to trick you with a multiple choice. See how this looks here? You've got the 8.26 times 10 to the minus 4th. If you forget to do that unit conversion and don't put it in kilograms and you left it in grams, you would have gotten E as the answer. So be careful, make sure those units cancel out and you get the right units that you're looking for. Okay, so those are the answers for in-class activity part B for solutions.